Hello, my name is Carlos. I'm founder and CTO of PFP Cybersecurity. We develop integrity assessment solutions based on dynamic power behavior and machine learning. In this video, we will show the ability of PFP technology to detect tampering across different devices and to track the adversary's lateral movement through different networks as part of their cyber kill chain. The demo setup is representative of what you would see in critical infrastructure. We have an industrial controller implementing a basic tank level control application. When the sensors indicate that the pump is empty, turns the pump on. When the tank is full, turns the pump off. The HMI shows the status to the operator, and the whole process control section uses a separate isolated network. The IP camera, on the other hand, resides on a demilitarized zone network exposed to the internet. The switch is the one responsible to enforce the isolation rules between the different networks. We have one PFP monitor for each device. This one is monitoring the IP camera using DC current measurements. This one is monitoring the Cisco router, the Cisco switch, using EM probe that is placed in one of the network cards. And finally, the PLC is being monitoring again by an EME probe that is placed right on top of the processor. PMOS are sending the integrity assessment results to our P3 scan enterprise cloud analytics. That is being shown on the main screen. Right now, all the devices are showing a clean state. The one at the top is the IP camera, the one in the middle is the switch, and the one at the bottom is the PLC, the IC controller. The attackers first gain a foothold in the system through the IP camera by exploiting an API vulnerability. From there, they proceed to attack the switch. It starts by exploiting a buffer overflow and delivering a 3-stage payload that breaks the isolation between the networks and allows them to reach the PLC. All right, here's where I actually have to run it. So, right, we immediately detect how the IP camera gets tampered, and right at the same time, the router is being attacked. So they move to the switch. So the attack is currently tampering the switch to break the network isolation. As soon as they're able to reach the PLC, the attackers will reprogram it using the same type of code injection used by Stuxnet. After this, the attack will remove itself from the devices to avoid detection. So let's give it a minute until we get the attack. Still waiting. Takes a couple minutes. It will happen. Okay. And almost. Now the attackers actually reach the PLC and they turn the pump on. Immediately as that happened, we can see how the PLC the PLC, the PMON monitoring the PLC was able to detect the tamper. So this completes the demo. We show you the ability of PFP technology to detect tampering by monitoring unintended analog emissions across different devices, and also track the adversary's lateral movements in real time through different networks as part of the cyber kill chain. Thank you very much.
And scene.